While this is going on, while we figure this out, hi, I'm David Rich. These are my partners. We have David Schwartz and Akira Suzuki. And our topic today is supercapacitors. You've already been explained by another group, but we're doing that as well. So we actually made those this morning as part of our lab. We created sort of a crude supercapacitor that actually worked. We were able to charge it using a USB, and then after turning the initial battery source off, it was still able to power a small LED without any external power. So we actually made our drawing is up there, and I believe Akira will explain that later. One thing you've heard a lot about sort of nano roughness and how surface area makes a big deal in these sort of things and why nano is so good. One thing we learned actually is that we had a very small amount of activated carbon, which we used for our supercapacitors, and 1 gram of the substance, which is almost nothing, has the same surface area as a football field, which is pretty nuts. Also, to give you an idea of nanoscale, the things that they're working with are about 1 to a couple hundred nanometers, and 1 tennis ball has the diameter of about 100 million nanometers. So these are things just on an incredibly small scale. To add to their examples of trains which can be powered by supercapacitors, another example that I found was a drill. So typically a cordless battery drill you can use it without a cord and it'll power, but a supercapacitor powered one will only last for half the time. However, it can reach its full charge in only 90 seconds. So that's another use of supercapacitors in normal life. They're very useful, and Akira can explain to you how they work.
Should I explain about batteries and like other stuff first, or should I just go right into it?
You are in charge of your presentation.
Okay. Well, there's in this analogy of a pastry place, they have a jelly donut on the left, powdered sugar donut, and then a powdered sugar funnel cake on the right. And basically, batteries are slow, but they can carry more capacity and electricity. And so that's why the jelly donut was used. It holds more sugar. Well, sugar is like the symbolism of electrons in this analogy. But so jelly donuts hold more, but like it takes longer to pump. I think that was like the meaning they were trying to convey here. So then, on the other hand, all the powdered sugar stuff are much easier to like pour on the sweets. And then it says in the middle, I think, price reflects ease of sugar addiction. Addition, I'm sorry. Yeah. All right, well, yeah, so that the price is basically showing the difficulty of adding in the sugar into the sweets. So basically, supercapacitors use a lot of small-scale particles in order to maximize surface area. So that's why, well, that's what we were told. So that's why they discharge and charge faster than the normal capacitor. That was our understanding. No. Oh yeah, they fixed it, didn't they?
They discharge faster than a battery.
Yeah, so basically it tries to use the same mechanics as a capacitor, which is supposed to discharge fast and charge fast, but have a little more capacity like a battery. I think that's what they were trying to convey, but yeah.
So one thing that was not displayed in this picture, which they could have put in, well, admittedly it would be pretty hard to include this, was specifically how a capacitor is different than a battery. So the difference comes from like the fundamental design of the battery versus the fundamental design of the capacitor. So in a battery, you have your electrons coming from a chemical oxidation reduction reaction, which occurs inside the battery, and this can take a comparatively longer amount of time. So in that time, you would get less electrons, which means you get less current, and then less power in a given time frame. So the capacitor doesn't do that chemical reaction. Instead, it has the ions in a solution. We used citric acid solution, and that allowed the electrons for the current to be conducted much more rapidly, and so that's how capacitors can provide much more power than a battery. So
I'd like to add one more thing, as well as the drill. Another application of supercapacitors, that they can be used to discharge power very quickly. So they could be used in an electric car to give very rapid acceleration or something, because they're able to give out a lot more power in a much shorter time. Also, I'd like to give a quick shout out to our leaders back there, Patrick and KJ, and Tori should be somewhere around there, not really sure, but they helped us and dealt with us this whole week, so thank you to them. Any questions? Sarah.
Okay,
Sarah.
Two questions for you.
Yes.
First, in light of the discussions you had the first time, how would you change the prices on your food to reflect the ease of sugar addition?
Yes.
And the second one is, the group who drew this did something incredibly cool and insightful that you did not comment on, relating to the nature of the jelly donut and the powder and the funnel cake, and for all of them. So can you comment on specifically why did they pick a jelly donut? That was not a happenstance. That was a really cool choice. So can you tell us why? But first do the money thing.
All right. Well, the first question was about the pricing of these things and the symbolism for that. Well, on the right side, there's a powdered sugar donut and then the funnel cake. They should be switched in price because the funnel cake is supposed to be symbolizing a supercapacitor because of its surface area. But in the previous discussion, we said that a supercapacitor is actually slower to discharge and charge than a normal capacitor. So, so the $2 and $1.50 should, yeah.
Comment on the jelly donut.
I guess jelly would be quite a sugar-dense way. Also, it is put inside. It is not outside. So basically the way these supercapacitors work is rather than storing the energy in chemical reactions. Yeah, I know, but so the supercapacitors actually just store the electron on the outside, on the surface. That's why surface area is so important, because if you have a lot of surface area, you'll have a lot of space to store electrons. So if the powdered sugar in this metaphor are the electrons, then they would be stored on the outside of the funnel cake and the donut, where the jelly would be the same as a battery, which would be some sort of like fluid inside of a battery.
The battery does a reaction inside the material of the battery. All the capacitors are a surface storage technique. So I just want to flag this as an example that anybody could understand. Like if you're trying to say to a 6-year-old, how is a capacitor different from a battery? You can say, it's like a jelly donut. The battery happens on the inside. And the capacitor is only on the surface. That's an analogy that anybody can understand. So.
Yes. Any more questions? Oh, one more?
I don't know how much you guys talk about commercial applications, but a car has a battery.
Sure.
It's a deep cycle battery. It can start a car many times before it dies. But you can also buy things that just jumpstart the car if your battery is dead. Are capacitors more likely to be used in those? I mean, are they used for something like that?
I am not sure if they're actually used in those products specifically. I know that they cannot be used in, well, electric car batteries at least, because they don't have the capacity for long range delivery. I'm not quite sure whether like immediate jump starters of batteries would be used with supercapacitors. However, I think that they don't fully recharge the battery. They just give it enough to start a motor, and then the alternator will charge the battery on its own in the car. So I don't know if you guys know any more about.
Wait, were you referring to using one car to start another car?
No, he was referring to like an external source. Yeah. Yeah.
Yeah, those jump starters are a little bit better now because it's just getting cheap enough for you to buy. But I think in terms of the application for the jump start, it mostly to get enough voltage to break down and cause that to go. And so that doesn't leverage much. You're just trying to jump, create enough voltage to create that one spark to go. And that's not the best use of our supercapacitor anyway, because you can generate enough voltage without a certain minute of time. Enough current to be able to generate the voltage. But in terms of maybe the other, how people apply supercapacitor now, I think all of you guys have a supercapacitor in your pocket, so maybe you can just explain that quick application, and then you can quite quickly see how people are using supercapacitor now. So can you show one demonstration of your supercapacitor you might have?
You mean the phone?
I'm gonna infer that you meant a phone by that.
So
yeah,
it can charge quickly.
Where would be a supercapacitor in this one, and then you can see and explain why that would be needed versus a battery.
So one benefit. One
So point out where the supercapacitor in the phone is.
is
the
it?
charging dock. The charging dock. Oh. Inside the phone.
So now, okay, so this might be a long question. The point is, why would you need, you have a battery there clearly,
Yes.
why would you, why would you,
The flash.
Oh, I thought.
why a flash requires a supercapacitor versus a battery
Smart.
that has a big battery?
Well, the flash is like an instantaneous like flash of light. So like, I mean, you don't really need the capacity to like shine like extensive amounts of light. Just flash and there, that's it.
Like a large release of energy at one moment.
Yeah.
I thought you were just taking a picture of us. Actually, I didn't get the metaphor.
And then that's actually where the applications are. When you suddenly have power really fast, I think in the docks, right, they have these elevators that actually loses a lot of energy because they have to lift something heavy so high, and that's a lot of energy. And then you try to capture it when you drop it down because that's free gravity energy, except that there's not enough material to be able to capture that energy fast. And so normal battery won't be able to capture that, recover that energy, but something that can fast and quickly take those powers, either deliver or capture, will be able to do that. And so these are all the applications that are coming out right now. Okay? I mean, Tolbert and her colleagues are experts in this in the world. I mean, one electricity world ever. And so she can probably speak proof about this than I would.
Oh, we can't, because we have to go on, because we're almost out of time. Yes.
Thank you very much. Thank you all for coming.